Welcome to the alternative hit demo. The purpose of the alternative hit is to take that clean spectra that we talked about and to go to a library like NIST and to cross-check that library to find out whether there actually is a better spectral match than the target that we've assigned it to. And the idea here is that we want to reduce false positives. So the question of an alternative hit, better match score coming from a entry in the NIST library, that information is stored in a column called alternative target hit. And you can see I've added that column here, and we'll explore that in terms of the report that is part of this workflow. All right, for the demo, let's take the case of simazine, which we already know is a false positive, and when searched against the NIST library, we're going to find out that it finds a better library match score, atrazine, very related compound. It puts that information into this column, alternative target hit, as you've seen here. So let's take a look at generating the report. This report will generate two different kinds, a summary report and a graphics report. So we'll start those up. And in the graphics report, we'll actually see the information that it's concluded here. So let's take a look here at 11 minutes. There's simazine, and we can see the retention time difference from the expected. But what you'll see below it in blue is that atrazine has been found by searching the NIST library with a better library match score, and that came out as hit number 1. Let's take a look now at the detailed graphics report, which has the bookmarks. So let's look down into this particular sample, and we can see the compounds that are documented here. Let's take a look at simazine. And here we have the graphical presentation of that same information. There's atrazine with a better library match score. And if we go down here, you can see that this is the spectrum that was retrieved from NIST, which got that better library match score, also documented the qualifier ratio and the clean spectra that was used to search the NIST library. So let me walk through setting up the method in the method editor. We'll go to the wizard and we'll show you the wizard. Now first let me point out, with alternative peak, we used a reference. That's a match. It's not a searching, it's a match to give you a library match score. What we're going to do here is set it up for searching. That's the alternative hit, and we're going to use the NIST library. So we're going to set up a library method. Now the library method will override the reference library. We still respect the reference library if it's a standalone, but the library method rules. So let's take a look at the library method that is set up here for target deconvolution 2. The library method for the peak detection algorithm, we're using deconvolution. That provides the clean spectra. So deconvolution has a lot of choices here. We'll leave those as the defaults. The main item here is that we've set up the library search to search two libraries. The first one by convention is the reference library, and that's what's used to give you the reference library match scores. That is not searching, that's just referring to a known library reference and giving you a match score. This second library by convention is used to do the searching in target deconvolution 2. And we've set up the NIST library here, NIST 11, and that will go ahead as a second library and use that to search for alternative hits. The other part of the method setup is the compound identification, and we've set the max hit count to 100. So it will go to NIST and pile up a list of up to 100 hits, which will meet this minimum match score, and then compare it against the target match score. And if any of those have a better library match score than the target that you found, it will provide that information to you as an alternative hit. So it will keep a maximum hit count of 100. That is patterned after the ChemStation DRS, Deconvolution Report System approach. For the sake of completion, the target match tab is not really part of the TD2 workflow, but this and the blank subtraction are used when going from target analysis quant out to unknowns. Thanks for your attention.